it's just very difficult to make hydrogen and store it and use it in a car.
Imagine a world where your car could run on nothing but water because we are 70% water and only 30% land. We tried to create something new and it's not just basically a copy of the form factor of everything else, but you still want it to be great. It's very hard. This is a very hard thing. A technology so revolutionary it could reshape the entire automotive landscape. Like it's physically possible, so I think we can do it. Every truck that we put on the road that replaces a diesel truck is a huge amount of leverage, and so that is why we're doing this and makes a huge difference towards driving us towards our total mission of sustainable energy and transportation. Elon Musk, the visionary behind Tesla, SpaceX, and countless innovations, may be on the brink of doing just that. You know, people always want to know what our next product is. We are actually building a new product. We are actually designing a new product, 2 new products, that I think you will be very excited about. Elon Musk's vision has always pushed the boundaries of what we consider possible. From electric cars to reusable rockets, his name is synonymous with innovation. But what if I told you that his next big idea could change the automotive industry in ways we never imagined? Today, we're diving into the world of water-powered engines and discussing the rumors and facts surrounding Musk's reported interest in this technology. For years, the concept of water as a fuel has captivated scientists, engineers, and dreamers alike. The idea that something as abundant as water could power our vehicles, potentially eliminating the need for gasoline and reducing our carbon footprint, sounds like something straight out of a science fiction novel. And yet, as we'll explore, it might be closer to reality than you think. Water-powered engines, or hydrogen fuel cells, represent one of the most fascinating alternatives to traditional fossil fuels. Unlike electric vehicles that run on lithium-ion batteries, hydrogen fuel cells generate electricity through a chemical reaction between hydrogen and oxygen. The byproduct of this reaction? Pure water. No greenhouse gases, no toxic emissions, just water vapor. While the idea of using water to power vehicles sounds revolutionary, the technology behind it is complex. Hydrogen fuel cells split water molecules into hydrogen and oxygen through a process called electrolysis. Once separated, the hydrogen is stored in fuel cells where it can react with oxygen to produce energy. This process generates electricity that powers the motor, much like a battery in an electric car. For years, hydrogen fuel cells were overshadowed by battery technology due to the latter's growing popularity and advancements in battery life and efficiency. Companies like Tesla, spearheaded by Musk, have invested heavily in electric vehicles, or EVs, effectively positioning batteries as the future of the automotive industry. However, with the recent advancements in fuel cell technology and the increasing need for sustainable solutions, hydrogen is gaining traction as a viable alternative. But why would Elon Musk, a staunch supporter of battery-powered EVs, be interested in hydrogen fuel cells? It's no secret that Musk has previously dismissed hydrogen fuel cells, calling them fool cells, and a mind-bogglingly stupid idea. Musk's primary argument was that hydrogen is inefficient compared to lithium-ion batteries, which he believes are the superior technology. So what's changed? As Tesla continues to expand its product line and push the boundaries of innovation, Musk's perspective might be evolving. Hydrogen fuel cells offer unique advantages, especially in applications where battery technology faces limitations. For example, fuel cells can provide greater energy density and faster refueling times than batteries, making them an attractive option for heavy-duty vehicles like trucks, buses, and even airplanes. In addition, hydrogen can be produced from renewable sources such as water through electrolysis, which aligns with Musk's goal of creating a sustainable future. Recent reports suggest that Musk has quietly invested in hydrogen research and development, possibly even exploring a water-powered engine concept for Tesla's next-generation vehicles. While Tesla has yet to make an official announcement, rumors are circulating that Musk's team is working on a prototype that could revolutionize the industry. If successful, a water-powered engine could eliminate the need for traditional fossil fuels, reducing emissions and making transportation more sustainable. The automotive industry as we know it relies heavily on gasoline and diesel, both of which have significant environmental impacts. The production and burning of these fuels release vast amounts of carbon dioxide, contributing to global warming. Electric vehicles offer a cleaner alternative, but they still rely on electricity often generated from fossil fuels, and their batteries require rare materials that are challenging to mine and dispose of responsibly. A water-powered engine could change this equation entirely. Hydrogen fuel cells produce only water vapor as a byproduct, making them one of the cleanest energy sources available. If Musk were to champion this technology, it could pressure other automakers to follow suit, potentially disrupting the entire car industry. Imagine a future where our vehicles run on water instead of gasoline, reducing pollution and paving the way for a cleaner, greener planet. However, transitioning to hydrogen-powered vehicles is not without its challenges. One major obstacle is the infrastructure needed to produce, store, and distribute hydrogen on a large scale. Unlike gasoline or even electricity, hydrogen requires specialized equipment and facilities. Building a hydrogen refueling network would be costly and time-consuming, but with the right investments, it could become a reality. Another challenge is the cost of hydrogen production. Electrolysis, the process of splitting water to obtain hydrogen, requires a significant amount of energy. If this energy comes from fossil fuels, the environmental benefits of hydrogen are diminished. To make hydrogen truly sustainable, we would need to use renewable energy sources like solar or wind to power the electrolysis process. This would make hydrogen production both clean and sustainable, aligning with Musk's vision of a renewable future. If Elon Musk does indeed pursue hydrogen technology, it could accelerate the development of a hydrogen economy. With Musk's influence and resources, Tesla could lead the way in building hydrogen infrastructure, making it more accessible and affordable. This would not only benefit Tesla, but also pave the way for other automakers to adopt hydrogen technology, creating a ripple effect throughout the industry. In addition to hydrogen's potential in transportation, it could also play a significant role in energy storage. Renewable energy sources like solar and wind are intermittent, meaning they don't produce power consistently. Hydrogen can act as a storage medium, allowing excess energy generated during peak times to be stored and used later. This could make renewable energy more reliable and scalable, further advancing Musk's vision of a sustainable energy ecosystem. The concept of a water-powered engine is not new. Inventors and engineers have been experimenting with hydrogen fuel cells for decades, but the technology has faced numerous hurdles. Safety concerns, high costs, and lack of infrastructure have all hindered its development. However, with Musk's track record of overcoming obstacles and pushing the limits of what's possible, he could be the catalyst needed to bring this technology to the mainstream. Imagine a world where Tesla's water-powered engine becomes a reality. The impact on the environment, the economy, and society as a whole would be profound. Gas stations would be replaced with hydrogen refueling stations. Oil companies would face unprecedented competition, and the demand for fossil fuels would plummet. This could lead to a cleaner planet, reduced greenhouse gas emissions, and a more sustainable future. Elon Musk's ambition to potentially introduce a water-powered engine or integrate hydrogen fuel cell technology into Tesla's lineup would be nothing short of revolutionary. To reach a 10,000-word deep dive, let's expand on this concept, detailing everything from the scientific principles behind hydrogen fuel cells to the potential global impact of adopting this technology at scale. We'll also explore the technical, economic, and societal shifts that could unfold if Tesla and Elon Musk move forward with this groundbreaking vision. The topic raises many exciting possibilities for the auto industry, energy sectors, and global infrastructure, not to mention potential environmental and political ramifications. So let's look at how this technology could disrupt traditional energy dynamics, reshape urban planning, influence geopolitics, and most importantly, redefine Tesla's role in the future of global transportation. The mechanics of water-powered vehicles, how hydrogen fuel cells work. At the heart of this potential innovation is hydrogen fuel cell technology. To understand its transformative potential, let's first look at how it actually works. Hydrogen fuel cells generate electricity through a chemical reaction between hydrogen and oxygen. In simple terms, the cell splits the hydrogen molecule into protons and electrons. These electrons are used to generate a current, which powers the motor and other systems in the vehicle. The only byproduct of this process is water vapor, making it an incredibly clean energy source. When we think of water-powered engines, it's easy to get caught up in the idea of just adding water to a tank and driving off. However, a more accurate description is that these vehicles would run on hydrogen extracted from water. Electrolysis, the process of using electricity to split water into hydrogen and oxygen, is essential here. This hydrogen can then be stored and used in the fuel cells to generate electricity. While this process does require energy input, advances in renewable energy could make this part of a truly sustainable cycle. Why Elon Musk may be reconsidering hydrogen fuel cells. Musk has historically dismissed hydrogen fuel cells, but his current stance on sustainable and scalable energy solutions may be evolving due to several factors. Energy density and refueling time. Hydrogen fuel cells offer advantages over lithium-ion batteries in terms of energy density, which could make them ideal for longer-range applications. Refueling a hydrogen-powered car takes just a few minutes, compared to the longer charging times associated with electric vehicles, EVs. For commercial transport fleets, buses, and even airplanes, this reduced downtime is invaluable. Environmental pressures and resource limitations. Lithium-ion batteries require minerals like lithium, cobalt, and nickel, which are finite resources. Mining these materials has environmental and ethical concerns, especially in regions where regulations are lax. As the global demand for EVs grows, sourcing these materials sustainably becomes increasingly challenging. Hydrogen, by contrast, is the most abundant element in the universe and can be produced from water, providing a theoretically unlimited supply. Urbanization and infrastructure. With rapid urbanization and increased EV adoption, the pressure on power grids and charging infrastructure is intensifying. Hydrogen could alleviate this strain by creating an alternative network that operates independently of the existing grid. Musk's understanding of infrastructure could be pivotal here. He could help develop a decentralized system that allows for broader adoption without placing undue pressure on any single part of the energy supply chain. System that is as sustainable as it is efficient, mitigating resource scarcity. The mining of lithium, cobalt, and other minerals required for batteries has significant environmental costs. Hydrogen fuel cells, by contrast, require fewer rare materials. While they do require platinum as a catalyst, advances in catalyst technology are reducing this dependency, making fuel cells more sustainable in the long term. Technical challenges and solutions in hydrogen vehicle adoption. While hydrogen offers vast potential, several technical challenges must be addressed before Musk or any automaker could successfully bring a hydrogen-powered car to market. Here's a look at some of the key challenges and how Tesla might address them. Storage and distribution. Hydrogen is notoriously difficult to store and transport. It requires high-pressure tanks, and building a network of hydrogen refueling stations is a major logistical and financial challenge. However, Tesla could leverage its experience in building supercharger networks and potentially partner with energy companies to create a hydrogen refueling infrastructure. Cost of electrolysis. Producing hydrogen through electrolysis is currently more expensive than extracting it from natural gas. If the electricity used in electrolysis comes from renewable sources, costs can be high and production rates can be inconsistent. However, advancements in solar and wind energy, along with potential subsidies for green hydrogen, could make electrolysis more cost-effective. Public perception and market demand. Battery-powered EVs have a well-established market, and convincing consumers to switch to a new technology is a challenge. Tesla's strong brand and Musk's ability to generate excitement around new technology could help overcome consumer hesitancy. By positioning hydrogen vehicles as the next step in sustainable transportation, Tesla could drive demand and shift public perception. Potential global impacts, geopolitics, and the hydrogen economy. Transitioning to a hydrogen-based transportation model could have major geopolitical ramifications. Here's how the adoption of hydrogen fuel cells could alter global dynamics. Energy independence. Hydrogen production can be localized, reducing dependency on foreign oil. Countries could produce hydrogen domestically, fostering energy independence and reducing vulnerability to oil price fluctuations. This shift could weaken the influence of major oil-producing nations and change the balance of power in global energy markets. New alliances and trade networks. Hydrogen production could create new trade alliances and economic networks. Countries rich in renewable resources could become major hydrogen exporters, creating economic opportunities and fostering new relationships. Environmental diplomacy. A global transition to hydrogen could drive international cooperation on environmental issues, encouraging countries to invest in sustainable technology and share innovations. This could have a positive impact on climate negotiations as nations work together to reduce carbon emissions. Tesla's strategic position. How hydrogen could fit into Musk's vision. If Musk were to incorporate hydrogen technology, he would have the chance to redefine Tesla's position in the energy market and accelerate his vision for a sustainable future. Here's how hydrogen could align with Tesla's goals. Energy as a service. Tesla could offer hydrogen as part of an energy as a service model. This would integrate with Tesla's solar and battery products, creating a comprehensive ecosystem where customers could generate, store, and use clean energy seamlessly. Expanding market reach. Tesla's current EV lineup is primarily focused on consumers. However, hydrogen fuel cells could allow Tesla to target new markets, such as commercial and heavy-duty vehicles. Hydrogen's energy density makes it ideal for long-range and heavy-load applications, providing an opportunity for Tesla to enter the freight and aviation sectors. Global leadership in sustainability. Adopting hydrogen fuel cells would reinforce Tesla's commitment to sustainability. This could attract environmentally conscious consumers and position Tesla as a global leader in clean technology, helping Musk achieve his mission to accelerate the world's transition to sustainable energy. 1. The science of hydrogen fuel cells, a closer look at the mechanics and chemistry. Hydrogen fuel cells, unlike traditional combustion engines or lithium-ion batteries, operate on the basis of an electrochemical reaction between hydrogen and oxygen to produce electricity. At its core, the reaction strips hydrogen atoms of their electrons, creating both a current and water as the only byproduct. Let's dive into the technical aspects of this process. To begin, hydrogen atoms enter the fuel cell's anode, where they are separated into protons and electrons by a catalyst, often platinum. The protons pass through a membrane to the cathode, while the electrons take an external circuit, creating an electric current. At the cathode, electrons recombine with the protons and oxygen from the air, generating heat and water. Unlike combustion processes, which are about 25 to 30% efficient, hydrogen fuel cells can reach efficiencies as high as 60%, which is an enormous leap in potential energy utilization. Yet the hurdles are substantial. Platinum is expensive, and alternative catalysts are in development but remain less effective. Moreover, to store hydrogen, we require high pressures and extreme cryogenic cooling, both of which demand high upfront costs and specialized infrastructure. Thus, the push for cost-effective hydrogen storage and efficient catalysts is crucial for hydrogen fuel cells to become mainstream. Musk, who has championed battery electric vehicles, has previously expressed skepticism about the inefficiencies and infrastructure challenges of hydrogen. If Tesla pursued this avenue, it would require a revolution in production, storage, and infrastructure. 2. Tesla's unique position to influence and innovate hydrogen infrastructure. Tesla is uniquely positioned to drive innovation in hydrogen fuel cell technology if it chose to do so. Through the supercharger network, Tesla already has experience developing infrastructure on a massive scale. Though hydrogen refueling is different, this experience is a significant asset. Building a hydrogen refueling network would require extensive investment and collaboration with energy providers, governments, and environmental organizations. Tesla's integration with SolarCity presents an intriguing opportunity. Imagine a setup where solar energy powers electrolysis at refueling stations, converting water to hydrogen on site in a carbon-neutral process. Such a setup would make hydrogen production sustainable and further decentralize energy. Tesla could use its experience in renewable energy and energy storage to make this model viable. Of course, such a vision requires the support of regulatory frameworks, government subsidies, and industry-wide collaboration. Tesla could also partner with countries looking to transition to green hydrogen economies. For instance, Germany and Japan are investing heavily in hydrogen, viewing it as an essential element of their future energy strategy. By partnering with these countries, Tesla could help build out hydrogen infrastructure globally, bringing hydrogen refueling stations to major cities and highways. If executed well, this could even surpass the company's supercharger network in impact and scale. 3. Economic considerations, cost-benefit analysis of hydrogen versus electric batteries. Let's delve into the economic side of water-powered engines. While hydrogen has certain advantages over lithium-ion batteries, it's essential to consider the full cost-benefit landscape, from the vehicle's lifetime costs to the impact on energy markets and global economies. Hydrogen vehicles typically require high initial investment costs due to fuel cell stack production, hydrogen storage, and refueling infrastructure. However, over time, advancements could bring down these costs, especially with the advent of alternative catalysts and improvements in fuel cell longevity. If Tesla or its suppliers could develop a fuel cell that costs less to manufacture and maintain, it would drastically shift the cost-benefit balance in hydrogen's favor. The potential long-term savings on fuel costs make hydrogen a compelling option. In areas with abundant renewable energy, hydrogen could be produced for minimal costs during off-peak hours. This could lead to variable pricing models where hydrogen is cheaper at certain times, incentivizing off-peak refueling. Tesla could also offer a subscription model, similar to their full self-driving package. Customers might pay a monthly fee for unlimited hydrogen refueling, which would allow Tesla to manage costs effectively while providing predictable clean energy access for its users. 4. Environmental impact, comparing life cycle emissions of hydrogen and battery electric vehicles. When we consider emissions, both direct and indirect, hydrogen fuel cells and battery electric vehicles each have strengths and weaknesses. Hydrogen fuel cells emit only water vapor, which is beneficial for urban air quality. However, the production of hydrogen, especially if derived from natural gas, can be carbon-intensive. The current industrial methods for hydrogen production, mainly steam methane reforming, emit significant CO2. However, with renewable-powered electrolysis, we can produce green hydrogen, which has near-zero emissions. If Tesla were to invest in a green hydrogen supply chain, the life cycle emissions of hydrogen vehicles could drop below those of electric vehicles, especially in regions where the grid relies on fossil fuels. Another consideration is resource extraction. Electric vehicles depend on minerals like lithium and cobalt, which have environmental and ethical concerns tied to their mining and extraction. Hydrogen fuel cells require rare metals like platinum, but at much lower quantities. Over the long term, green hydrogen could offer a cleaner, more sustainable alternative to battery EVs.